in this lesson, you should be able to identify a pattern in a sequence, identify if a pattern is arithmetic or geometric, and be able to write its equation. Arithmetic and geometric sequences. Arithmetic is based on a constant addition to get the next term. Geometric is based on constant multiplying to get the next term. So highlight those. And we talked about already, your recursive definitions are based on the previous term. So given f of 1, then f of n equals the previous term plus the difference. Or you're given a sub 1, then a sub n equals a sub n minus 1, the previous term, plus d. So these are the same thing, just written in different forms. Function form, subscript form. D is what you're adding, also known as the common difference. And if you're adding, you're going to be going up in your sequence. If you're subtracting or your common difference is negative, you're going to be going down. So let's generate the next three terms of the given arithmetic sequence. So in part A, we have function notation. Some term equals the term before it plus 6. So this is our common difference. So if the first term is 2, we need the next 3. So the second term is the first term plus 6. So your second term is 8. Your third term is your second term, your previous term, plus 6, which is 14. And your fourth term is your previous term, 3, plus 6, which is 20. So again, we start out with a term, we take that, we plug it in, we get the next one. We take that, we plug it in, we get the next one. We take that, we plug it in, we get the next one. All right, so this one is in function notation. Now we're in subscript notation. This one, your common difference was 6. This one, your common difference is 1/2. So your second term equals your first term plus 1/2. So 3/2 plus 1/2 is 4/2, which is known as 2. Your third term is your second term plus 1/2. Well, 2 plus 1/2 is 2.5, or 5/2. And your fourth term is your third term plus 1/2. So 5/2 plus 1/2 is 6/2, or 3. You may have to use a calculator to add those, and that would be okay. Go ahead and read exercise 2. See if you can figure it out without me, and then play the video. All right, so I set up my 3 terms. Now, in order to find what I have to add to this to get this, has to be the same as what I add to this to get this. So let's go back and review. What I add to 8 to 14? 6. What did I add to 14 to 20? 6. How did I find that? Well, the second term minus the first term is 6. The third term the fourth term minus the third term minus the second term. The difference between each one is a constant difference, or a common difference. So what is the difference between this one and this one? What do I have to add? 2t plus what equals 5t minus 1? Well, 2t plus what is 5t? 3t. Nothing plus what is -1? -1. So that common difference is 3t minus 1. This is rather challenging. Now, what do I have to add to this one to get this one? So 5t minus 1 plus what has to equal 6t plus 2. So 5t plus what is 6t? T. -1 plus what is 2? 3. Well, guess what? These common differences have to be the same. These are both d, and they have to be equal. So 3t minus 1 has to equal t plus 3. So subtract t. So 2t minus 1 equals 3. Add 1. So 2t equals 4, so t equals 2. So if t equals 2, what is my common difference? Well, one of them was t plus 3, so 2 plus 3 is 5. Well, what's 2 times 3 minus 1? It is also 5. So my common difference is 5. So now we have to go and find our terms. So 2 times t, well, if our common difference is 5, all right, so 2t plus our common difference of 5 has to give us 5t minus 1. So move your 2t. So 5 equals 3t minus 1. Add 1. 6 equals 3t. So t equals 2. So if t equals 2, what's 2 times 4? 2 times 2 is 4. So the first term is 4. 2 times 5 minus 1 is 9. 2 times 6 is 12 plus 2 is 14. Notice, what's our common difference? Our 5. So what's a of 4? Well, if you add 5, you get 19. So hopefully you listened and could follow all of that. It wasn't easy. If you find an easier way, share it with me in class. Determining a general term of an arithmetic sequence based on the value of the index variable. So consider that a sub n equals a sub n minus 1 plus 3, with a sub 1 of 5. Determine the second, third, and fourth terms. Well, again, this is recursive because this is some term and this is the term before it. So the second term equals the first term plus 3. Well, the first term is 5. So 5 plus 3 is 8. And again, you can see on here, this is your common difference. So the third term is the second term plus 3, which is 13. And the fourth term is the third term plus 3, which is, I didn't add 3 there. 11, which is 14. I was adding 5 in my head. Excuse me. So how many times was 3 added to 5 in order to produce 4? So just like we did in that other lesson, this is our term, and this is the number of 3's added. So in the first term, we have 0 3's added. In the second term, we've added it once. In the third term, we've had to add another 3, so that's twice. In the fourth term, we've added another one, so that's 3. So how many did we have to add in the fourth term? And your answer is 3 of them. So use your result from part B to quickly find the value of a of 50. Well, again, the relationship between the number of common differences we have to add is 1 less than the number of the subscript. So a of 50 is our first term 5 plus 49 3's. So go ahead and find that value. And you should have gotten a 152. So write a formula for the nth term of the arithmetic sequence a sub n based on the first term. Well, look, 5, we have to start somewhere, so that's your first term, plus, where did 49 come from? Well, it's 1 less than this. And what does this stand for? N. So we need n minus 1, and we're going to multiply by our common difference, d. And why don't we put d in parentheses? If you don't like it in this order, you absolutely could write it like this. So a sub n equals the first term plus the difference one less times than the number of the term you're trying to find. And this is called the explicit formula. And this is huge. You need to know this. So please make sure you have that down. So in exercise 4, given that a sub 1 is 6 and a sub 2 is 18 are members of the arithmetic sequence, so again we're adding, determine the value of a sub 20. So the first thing we have to know is, are we adding or are we multiplying? Well, arithmetic means we're adding. So now we have the first term, which is 6. We don't have the second, we don't have the third, we do have the fourth, which is 18. So we're missing the second and the third. So if it's arithmetic, I go from the first term and I'm going to add D and get the second term. And then from the second term, I'm going to add D and I'm going to get the third term. And then from the third term, I'm going to add D and I'm going to get the fourth term. That's an equation. And because we're adding, it's arithmetic. It's a linear equation. So we started with 6 and we added to it 3 D's and we got the value of 18. So subtract 6, 3D equals 12, divide by 3, D equals 4. Well, that's great. It didn't ask me for D. It asked me for the 20th term. So the 20th term equals the first term, 6, plus the common difference 4, one less times than the term I'm looking for. So I'm looking for the 20th term, so I have to multiply by 4 19 times, or n minus 1 times. So let's plug that in our calculator, and you should get an answer of 82. All right. Geometric sequences use a multiplicative constant instead of an additive one. So geometric is multiplying. Arithmetic is adding. So again, it doesn't matter with our recursive. Some term equals the term before, but because it's geometric, we're multiplying. If it's a subscript form, it's a sub n equals the previous term times r. Now it's called a common ratio. And again, it can be positive or negative and is often fractional. So again, this piece is the same and we're multiplying both of them by r. So generate the next 3 terms of the geometric sequence given below. So again, it's geometric, so we're multiplying. So the second term, we have to multiply by the first. The third term, we have to multiply by 2. The fourth term, we have to multiply by 2, because that's our pattern, is to multiply by 2. In B, what's our pattern? Some term equals the term before it times 1/3. So this is your common ratio, this is r. So your first term is 9. So that means your second term is to multiply by 1/3. So 3. Your third term is to multiply by 1/3, which is 1. And your fourth term is to multiply by 1/3, which is 1/3. If you can see the shadow, I'm being invaded by a 4-pawed friend. There she is. Go. All right, and part C. So we have T sub n. So they went from A's to function to now T's. You have to get used to all 3 different ways they can ask it. And this one has radicals. Yep. So again, some term equals the term before it times radical 2. So this is your common ratio. So the second term equals the first term, 3 radical 2 times radical 2. So radical 2 times radical 2 is radical 4. Well, radical 4 is 2. So this is 3 times 2, which is 6. The third term is 6 times radical 2, which is 6 radical 2. And the fourth term is 6 radical 2 times radical 2. So radical 2 times radical 2 is radical 4. The square root of 4 is just 2. So 6 times 2 is 12. That was a tricky one. Make sure you ask if you don't understand in class. All right. Like arithmetic, we also need to be able to determine any given term of a geometric sequence based on the first value, the common ratio, and the index. So the first term is 2, and our pattern is a sub n equals a sub n minus 1 times 3. So some term equals the term before it times 3. So this is our r. So what's the fourth term? Well, the second term is the first term times 3. So the first term is 2. 2 times 3 is 6. A sub 3 is the second term times 3. Well, the second term is 6, so 18. And the fourth term is the third term times 3, which is 18 times 3, which is 54. So again, how many times did you need to multiply 2 by 3 in order to find the fourth term? So this is the term, and this is the number of multiply by 2's. So in the first term, you gave it 0. It was just 2. In the second term, we multiplied by 1, 3. In the third term, we had to multiply by 3 again, so that makes 2 of them. And in the fourth term, we had to multiply by 3 of them. So again, the number that we're multiplying by is 1 less than the term we're looking for. So if I'm looking for the 10th term, I have to start with 2 times, what am I multiplying by? 3, 9 times, because I need 1 less than this. So a sub 10 equals my start value times what I'm multiplying by, my common ratio, 1 less time than the term I'm looking for. So my answer is 39,366. So when you multiply, your numbers are going to be a lot bigger or a lot smaller. So again, we have to write the formula. So 2 is my a sub 1 times 3 is my r value, raised to, here I use 9. 9 is 1 less than 10. 10 is my subscript, so that's my n value. So n minus 1. And please put r in parentheses. And that is your a sub n. And again, this is called your explicit formula. And you'll notice the box at the bottom, there they are. Please make sure you highlight that box, and we'll get it on an index card. Good luck.